Welcome Dr. Ling Fan. So Dr. Fan is the CEO of Design.com, a technology unicorn. Its mission is to build a digital infrastructure for creative resources for the next generation. So Dr. Fan is also the founder of Tongji University Design AI Lab. Today, he's going to share on the topic of the computability of narrative and the possibility of AI-generated content. Please welcome Dr. Fan.
Good morning, everyone. Thank you, really, Professor Wong, for inviting me to Hong Kong. It's been a while since I came to Hong Kong last time. Two disclaimers before my talk. First, I have two full-time jobs, both full-time. I'm a university. I teach at a university, but I don't like to be called a professor, so please call me Ling. And second, I run a company, but I don't like to be called a businessman. So I sort of work in between. And second, the topic I'm going to speak, rather than a conclusion, I prefer this to be a question that I'm really inviting further discussion with the audience, even maybe criticism and dispute. The topic I'm going to talk about is something that's really in a way, trendy recently with OpenAI, ChatGPT, all those stuff. I've been working on AI and design, AID, for over 10 years, and that's why sort of I think a touch upon this subject is very important and it seems relevant for this event. Before I go into what I do in a university and a company, I want to sort of step back a little bit to talk about a grand narrative. It is very interesting that the storytelling or the narrative actually drives human evolution. Just three very small slices. One is from sociology, the other from science, and the rest from economics. Three books. The first book, of course, a lot of you probably already read before, A Brief History of Humankind. It says that the reason why Homo sapiens survived among all the species because we gossip. We know what's not existing. We're sort of looking forward to something that's fictional. That's why we have vision, we have hope, we have dream, so that we live longer. We survive among the species. A better narrative helps us to survive. And the second, David Deutsch, one of the best scientific writers, actually wrote a book called The Beginning of Infinity. And the small words here says, explanations that transformed the world. He also argued that even in the scientific world, the mathematics, the physics, is also looking for better explanations, a better narrative. And last but not least, economics. The Nobel laureate, Professor Robert Shiller, wrote a book directly called Narrative Economy. The reason why we buy stocks, the reason why we believe cryptocurrency, a lot of things, the reason why we somehow think this year will be better than last year, is all built upon narrative. So narrative shapes human evolution. Well, it's a short conclusion, but let's start with that. And the content, everything. The talk today, wherever we see in the Times Square, wherever we see in the Central, where people speak, the images, texts, KOLs, influencers, etc., all these are contents everywhere. And everywhere that it's really the embodiment of all these kind of narratives. And there's a transformation which happens through the digitization. Before, if we think about how the product, how the brand sort of communicates with the consumer, the user, the end user, is actually through the channels, different channels, retail channels, let's say. But now, we center around the consumer. So we're not unfamiliar with human-centric, consumer-centric approach. And in between the consumer and the product, it's the content. Sometimes we don't touch the product before we actually purchase it, right? We didn't need to go to the shop to touch the product, to see the product, to smell the product anymore. we see the contents. We see the content from Instagram, or in mainland China, we see the content from the red. We call it the seeding, 种草, which means that there are a lot of videos that shows how the product's used. And then we decide to buy it, and we didn't touch the product until the product's delivered to our house. So my talk today, which sort of a sort of good counterpart to Dr. Maniro's talk. His talk is all about materiality, and my talk probably all about immateriality, which is good, right? It's two sides of the story. So this makes me really fascinated about how, in a digital world, we can understand content better from computation. So the first subject I want to talk, most of them are conducted as research in my lab in Tongji University, is about the computability of content. The first step, in order to compute, we have to turn the content to data. So we were so fascinated about turning all kinds of creative contents into data. This is the first thing we did, which is a data set. The data set called DesignNet. If we are familiar with the development of machine learning, artificial intelligence, we probably know 20 years ago, there's very sort of a seminal work by Professor Fei Li in Princeton University. She developed this called ImageNet. Basically labels an image with all the tags, child, face, building, lion, dim sum, chopsticks, etc., etc. What we're trying to do here for DesignNet, as ambitious as the ImageNet at that time, was try to teach the machine the sort of foundations of design. Imagine how are you going to talk design to a 7-year-old? What's the typeface here? What's the emotion that this image tries to express? What's the color combination, et cetera, et cetera. So up to now, we have aggregated over 1 billion content data. But unfortunately, almost 77% are labeled, so we still have a long way to go. This is called DesignNet, basically trying to build a textbook for the machine to understand graphic design. And then start from that, we do something more. This is a work by some of my students, basically try to teach the machine 100 design books. What is design? Sorry, it's in Chinese. What is design? What is color? So we basically build a knowledge graph through 100 canonical design books so that the machine sort of has the knowledge, can build the connections between different concepts of design. So it's really dumb. It's like if the first one, the DesignNet, is teaching 7-year-old, this is probably teaching freshmen. So you see what is design and what is color. And all these things start to build some foundation for design, the computability of design. And later on, we're not just happy to do the foundations. We want to do some cultural inquiries. This is work. These are the graphic designs called Chinese subculture style, which means if in a sort of a more classic design, green and red should not be together. But in a subcultural color set, this two means cool. So these are the sort of some color combination. We try to build a data set to understand the subcultural color combinations. As you can see, these are the colors that can be together, two adjacent to each other. And some of my students, we start to collect all the possibilities of the color combinations, as you can see here. And then we basically, later on, also add emotion into it, passionate, and the age groups into it. So in any given graphics, we're able to color this graphics to a sort of subcultural style. This is something that we do. Remember, this is 2021. The technology we use was just the last generation technology, GAN. And we cannot stop doing data sets of all the contents you see. We do these minifigures, quite sort of popular among the young kids. Figure types data sets, face and eyes ratio data sets, different themes data sets of minifigures, color combinations. Last but not least, even the price. We've been collecting over 100,000 minifigures to build these data sets. So I assume that we might have the biggest minifigure data sets in the world, which will be open source very soon. If you like to further work on the fashion of minifigures, we are very happy to open this to PolyU, to Ms. Wang. Okay, so let's come back to a more serious talk. We start to build this sort of a framework, the conceptual framework of the computability of content. If we think about, let's start with the content. If we go up, we actually would be able to understand the creator. And we go down, go more fundamental, asset, tag, and the data behind the data, which we call metadata. And then in my company, we build a software to collect all the content data. So we're working with over 100,000 creative teams, really to ask them to use this software to actually turn all the creative contents that they do, images, sound, 3D models. We are actually able to accept 70 different types of content data, and then we process them. And what's next? When we have the building the framework of the computability of content data, we're actually able to reverse this process to use the metadata. The metadata actually can generate asset, and then the asset can generate content. The content may be able to inspire creator to generate new knowledge. So this is what we call the possibility of AIGC, AI-generated content. Very early experiment, a commercial project, working with Garden Country, which is by then was one of the largest real estate developer. They hire over 1,000 marketing designers in their team. And then what we do is to really build a design engine for them so that, unfortunately, they can cut the headcounts and then to build things more efficiently and keep the brand consistency. That was 2019. That was very early on. And later, we sort of having a little fun to work with Shanghai municipal government to activate Jinshan Nongminhua, which is Shanghai traditional folk arts. So basically, you will see this kind of work in museums, in exhibitions that to showcase Shanghai. And basically, we try to invite the viewers to just draw very simple stuff, graffitis. And then the machine would generate Jinshan folk art for the viewers. It's intended to be very low-key. It's intended to be not as delicate as it was. And then you can share that on WeChat moments so that other people can participate as well. So instead of sort of preserve the folk art in a way as an exhibition, very sort of high art manner, what we try to do is to build a data set. So we also have a Jinshan folk art data set, and also to bring this to general public in a very low-key way. This is what we've been doing right now. We call it AIGC Playground. You see like a lot of foundation model, well, not a lot. Some foundation models are really groundbreaking. And then on top of that, remember we have tool that can actually collect content data. Right now we have over 1 billion content data, remember I said earlier. And then those are very important proprietary data to train the foundation model to be a proprietary generative model. So every creator can use the foundation model and use their own proprietary data to train a model. So this is sort of what we did. And among a lot of artists here, I'm sorry, these are all my hand drawings. My company's name is called Design. It's a compound word of tech and design. So Chinese pronunciation is called 特赞. One thumbs up is good, 赞, and 2 thumbs up is 特赞. So the logo is 2 thumbs up. So you see all these paintings are 2 thumbs up. Every Thanksgiving, I would draw a drawing with my iPad to send to my best staff. So all these are my best staff every year, almost every year, sometimes 2. And drawing one of these, you know, with my very limited skill, took like 2 hours, and I used fingers. Wow, spending a lot of the energy. And then so I decided to ask the machine to help me in the future, so that I can give every staff. I have 500 staff right now in my company, so I can help. I can draw one for every staff during in the Thanksgiving. So we use this about 8 assets to train the first generation model. And then this is the result that this model generates. Do you feel happy about it? Maybe not. It's not so good. But what we did next is that all these are my own hand drawings, but we picked some from the generated result that we are satisfied with, and then to generate the second generation model. So the second generation model with 21 assets, 8 of them are hand-drawn, and the rest was machine-generated. So that becomes the second generation, and the result gets better. So we do this, keep going. So every time we add some good generated result, so this model becomes a human-computer, sort of a compound model. And then this is one that I feel happy about to send to one of my colleagues. And then these are all the metadata. And at the bottom, there's one called content DNA. And what is content DNA? Let me explain. This is a very easy to understand code. Content DNA. Just like every human being has a DNA, it really records the genealogy of how you developed. So this content DNA of this image, it shows all this purple color are the ones sort of used to have input on this image. Ginkgo, one of my colleagues, used a prompt and to use this model generation tool to generate this content. And then this model generation tool was trained by Ouyang, another colleague of mine, and then based on the content generation 1. And then if we go further down, FL, that's me, input 8 pictures and then train the model using the Stable Diffusion, which is an open sourced foundation model. And then so in the content DNA, you actually can see how this image are gradually coming to being. And this is very important for us. You know, before, if we look at a JPG file, an image, you probably only see the size of the file, when it was created, who created it, but you can never record the creative process itself. And then so we turn this content DNA back into a workflow engine, so that this workflow generate this result. And then if we go further, we could actually add more workflows. We can use ChatGPT to produce a sentence, find a sentence on technology and creativity, basically my company's name, Tech and Design, and then put that into this template, and then to generate the result. This becomes the badge we hang on neck in the working around in the office. My name, a sentence that generated, found by ChatGPT, which was by Alan Kay, and then the number, and then this picture, and then it becomes a badge hang on the neck for the office badge. And then this becomes a workflow. Remember, this is generated result before with 2 models, and then add an input together. This is a sort of a human designer templates, design templates, and together workflow generates this result. So what we think here, the possibility, so-called, of the AI-generated content is not necessarily one shot. One shot means you just input and then the result comes out. It actually be integrated into a operation system that you actually can combine different workflows. So we are building this right now. And then last but not least, with this sort of a work, if it's a commercial work, let's say it sells well, 3 bags of goals. And then through this content DNA, you actually can come back to see different people's contribution. My contribution was to input that original image and then generate the first generation model. And then these 2 sort of fine-tunes model. And then this lady generates the second model. And Ginkgo, another lady, produced the final artwork based on the second generation model. So with our software was called Muse. So with the smart contract, we actually can record this process. If this sells $100, let's say, then this becomes a way to distribute the return. Just like Bitcoin, if you mine the Bitcoin, the Bitcoin you got is called a proof of labor, that you do the mining, right? What we would call this is proof of creativity. And eventually, this whole creativity input becomes, can be recorded. And then if something gets commercialized, it will actually be returned back to the creators that in every step that made the contribution. So this is my last slides. I think we started with the subject, the question, the computability of content and the possibility of AIGC, AI-generated content. I think this would be the sort of actionable things that we can do. Maybe you come for the tools, more advanced tools, more effective tools, but you actually stay for the economy. That would change the way how we work and how we distribute wealth. That's my talk, and thank you very much.
Thank you very much, Dr.